exercise we're going to do today that doesn't replace homework, that's in addition to the regular homework 4 that I posted earlier today. Okay, I want to make that clear. Of course, in-class exercise should be no extra work if you're here. We're doing it together. But that's not replacing the homework assignment. All right? And
Yes.
I'll give details later. I will hold a review session before the exam on Tuesday, the day before the exam. Okay. So, we've covered a lot of stuff. Don't want to have to go fast. So let's get started. So first of all, finish up what we almost finished up on Monday and didn't quite get it. So remember, we're doing the example, we're asking the question where the concentration of feed started dropping at a specific rate, and continuation of example question 2. From your y prime bar, which was, we have found out that y prime bar after step 2 was minus 5.55 times 10 to the minus 5 times 1 over s squared s plus 0.111 e to the minus 5 s, 5 galore. And from that immediately, from the dictionary, we could say that y prime of t is 0 for t less than our delay 5, which is what we have in the exponent here, and a delayed function h of t minus 5 for t greater or equal to that time, where h of t minus 5 is obtained from first obtaining h of t and then replacing t by t minus 5. And how do we find h of t? H of t is the inverse of h bar of s, and h bar of s is what? Is whatever multiplies the exponential. It's y prime bar without the exponential. So that's going to be equal to an inverse of minus 5.55 times 10 to the minus 5 times 1 over s squared s plus 0.111, which is of course the constant factors out of the inverse. So I can rewrite that as minus 5.55 times 10 to the minus 5 times the inverse of 1 over s squared s plus 0.11. And that's not in the dictionary, but we can get it from the dictionary by doing partial fractions expansion. So the partial fraction expansion for this is and using the quick and easy method, we immediately And for C11, what did we do? We can pick any value of S for this equation except where the denominators become 0, except 0 and minus 0.111. And also we should avoid any value close to it. We made the reason. Because computers are not different here. So, making our life easy, clearly 1 is far away from both of them, and makes immediately C11 equals. So, using, let's put here a star, using S equals 1 star, we find the remaining parameter. We find that C11 is equal to 1 over 1 squared times 1.111 minus C12, which is 9, over 1 squared, minus C21, which is 81, over 1.111. And if we do this algebra, that's what we stopped, we will get minus 81. So that's where we stopped last time. Okay? So we're almost home. So now that we have all the coefficients, we can go ahead and calculate h of t. So h of t is minus 5.555 times 10 to the minus 5 times the L inverse of 1 over s squared plus that, which we did the partial fractions expansion. So C11 we found is minus 81. So I have minus 81 over s. C12 was 9, so plus 9 over s squared. Yes? Okay.
Did you just choose s equals 1 because
Yeah, I can pick any value of s that is far from the points that make the denominator 0. And why I pick C11? Because then I immediately have C11 equal. When I pick s equals 1, because I immediately get C11 equals for s equals 1. But I could have picked 2, I could have picked 10, but I picked minus 10. We get the same answer no matter which one we pick.
What was the number that you picked?
1.
1.
Six.
I'm just behind.
Yes, it was 1. Okay. Right. So, C12 was 9, C21 was 81, so plus 81 over s plus 0.111. I'll remind you of the one entry dictionary that we have been using a lot. Remember that if f of t is t to the k over k minus 1 factorial e to the minus at, f bar of s is 1 over s plus a to the k. So what do I have here? I have constant over s. How do I get 1 over s? If I use k equals 1, k equals 0, and a equals 0, then that becomes 1. K equals 1. K minus 1, yes, that's the k equals 1. So I think t to the k minus 1 will come out. Please correct that. So if you use k equals 1, a equals 0, you get 1. And of course, that means that the Laplace transform of 1 is 1 over s. I have 1 over s squared. how do I get 1 over s squared? I get 1 over s squared if I have k equals 2 and a equals 0. Okay? Look from this side. I have 1 over s. How do I get? Yeah, I like this on this side. I need 1 over s. How do I get 1 over s from that? I get 1 over s if I take a equals 0 and k equals 1. How do I get 1 over s squared? I get 1 over s squared if I take a equals 0 and k equals 2. So that means, go on the time side, what do I get for a equals 0, k equals 2? You get you get t to the 2 power, to the first power over 1 factorial 1 equal to 0, you get t. Okay? So the inverse of 1 over s squared is t. See how it works? And how do I get 1? I have 1 over s plus 0.111. So how would I get 1 over s plus 0.111? I will put a as 0.111, and I would take k equals 1. So going to this side, for a equals 0.111 and k equals 1, I get e to the minus 0.111. Okay, it's really efficient.
Wait, you flew through that. You flew through that.
One, I have to be efficient. Today, guys, I can't stop for every single question. We have to cover material before the exam. I'm sorry. Ask me after class 1 on this. Okay? So, we know how to invert each one of them. Remember, that's a linear operator, which means the inverse of a sum of terms is the sum of the inverses. So, h of t, therefore, is going to be minus 5.55 times 10 to the minus 5 times. I'm adding up the 3 inverses. What's the inverse of minus 81 over s? Minus 81 factors out. 1 over s has 1, so that's minus 81. What's the inverse of 9 over s squared?
90.
90. What's the inverse of 81 over s plus 0.11? The constant times e to the minus 0.111. So that's h of t. Okay? So once I have h of t, I need to get, for the answer, h of t minus 5. So to get h of t minus 5, everywhere I see t here, I put t minus 5. I see t in 2 places. I forgot to bring the color chart. I see t here, and I see t here. So both of those t's will become t minus 5. So h of t minus 5 is equal to minus 5.55 times 10 to the minus 5 times minus 81 plus 9 times t minus 5 plus 81 times e to the minus 0.111 times t minus 5. Okay, everyone? So, I'm ready now. Y prime of t is 0 for t less than 5, and this for t greater than 5. And if I want the actual y of t, the actual y of t is the nominal value plus the deviation. Always actual variable is nominal variable plus deviation. So that means, and the nominal value for here was 0.02. So So that's equal, and that's the final answer. For t less than 5, I add 0.02 to 0, so 0.0200 for t less than 5, and 0.0200. Now, if you multiply this times minus 5.55 times 10 to the minus 5, you get plus actually, it's okay. I'll just leave it in that form. It's just algebra. So I'll just leave it in that form. Minus 5.55. You can do algebra to beautify it. 4.5 and a 5. This is fine. This is. If you did that in the exam, that's full credit. You don't have to work out the final numbers. This was for t less than 5, and this is for t greater or equal. Yes?
Since we have h of t minus 5 right above that, say in the exam, would it be okay just to put 0.0200 plus h of t minus 5? That's right.
Clear, everyone? Know how to do it? Okay. So, told you to bring your laptops. So, let's start. Okay, Juan, I'll use this screen.
Thanks. Hey, we missed some stuff that was on my part. I don't know if you did, but we did.
So, we're going to do that now with Excel. We're going to do first a straightforward example, and then we're going to do a more difficult one that has complex conjugate denominators. If you go to the class website, the new addition is in class exercise 1. Projects in a second. So let's go to the class website.